Hello, welcome to this video. This is 1-5 continuity for AP Calculus AB. We're going to go ahead and talk about continuity, and if you haven't watched lesson 1-4, which is on discontinuities, you'll want to go ahead and make sure you have seen that video or have some understanding about discontinuities. In that lesson, we went ahead and informally talked about continuity. We talked about these ideas that a function has a jump discontinuity if the limit from the left does not equal the limit from the right. And we also talked about if the limit exists, I still have to make that the function value, make sure that the function value there is equal to the limit. That way I don't have a hole. So today we're going to go ahead and formally define continuity. And here is the definition of continuity. The continuity at a point. A function f is continuous at x equals c when three conditions are met. The first one, the function value has to be defined there. F of c has to be defined. If it's undefined, it's not continuous. Condition number two, the limit from the left has to equal the limit from the right of f of x as x approaches a certain c value. And then condition number three, the limit of the function as x approaches c has to be equal to whatever that function value is. If not, I have a hole. So we'll go ahead and look at some examples of this when the following conditions do not hold. Now they say here, note for condition number two, when using a piecewise function, we have to find the limit from both sides to verify that the limit exists. Yes, that's what it means for the limit from the left to equal the limit from the right. So here we go. They say condition number one is true, but condition number two does not hold. Well, that's very, very easy. I can go ahead and sketch a piecewise function, something like this. And the function value here at c is defined, but the limit from the left is not equal to the limit from the right. Next they say condition number two is true, but condition number one does not hold. So the limit from the left is equal to the limit from the right. However, the function value is not defined. So here is an example of that. I have the limit equaling the limit from the limit from the left is equal to the limit from the right. However, the function value is not defined there. And then for the third example, they say conditions 1 and 2 are true, but condition 3 does not hold. Okay, so my function value is defined. The limit from the left does equal the limit from the right, but they're not equal. And I can just make a rough sketch of that same graph here. And there, the function value is defined, but it's not equal to what the limit is. So all three examples of these, at c, the function is not continuous, right? Two holes, two removable examples, and then I have a jump discontinuity, okay? All right, so let's go ahead and apply this idea, this formal definition of continuity. Here's example number 2. They say show that the following function is continuous at x equals 1. Okay, so for my class, what I want you to do is I want you to go ahead and just analyze, especially with a piecewise function, does the limit from the left equal the limit from the right? And I'm going to go ahead and, analyze the limit as x approaches 1 from the left of this function, f of x. Make sure you have f of x there, right, for your limit notation. Don't have any naked limits. And I'm going to go ahead and evaluate 1 for my piece from the left, which is 2x squared minus 3. So 2 times 1 squared minus 3. This gives me negative 1. The limit from the left is negative 1. Okay, what's the limit from the right? Well, the limit as x approaches 1 from the right of f of x is equal to the natural log of 1 minus e times 1 minus 1. Now, the natural log of 1 is 0. E to the power of 1 minus 1 is e to the 0, which is just 1. This equals negative 1. Hey, what do you know? The limit from the left is equal to the limit from the right. Yes! All right. One last thing to check. I have to see, okay, what is the function value? So I want to say, okay, what is f of 1? Is it defined? Is it equal to the limit, whatever that limit is, which is negative 1? And you'll see that 1 is part of the domain for our second piece. So yes, we already found that. That's negative 1. We have continuity. Okay? And then they don't ask us to explain or justify, but how I know that it is continuous, I'm going to say f is continuous at x equals 1. You would want to state the conclusion, but here they don't ask for justification, but I'm going to train you guys to be above the bar. We're going to go ahead and give a conclusion. Because the limit of the function f of x as x approaches that value at 1 is equal to the function value, which was f of 1. And for good measure, I'm going to throw in what that value was, which was negative 1. Okay? And there's a justification statement. So f is continuous at x equals 1 because the limit of the function as x approaches 1 is equal to the function value, which is negative 1. Okay. Example number 3. Is the following function continuous at x equals 3? Give a reason for your answer. Okay, so similar to exactly what we did in the last problem. Similar to exactly what we did. This is just like the last one. The limit as x approaches 3 from the left of g of x. This is going to be equal to 3 squared minus 5, which is 4. Okay, now what is the limit of g of x as x approaches 3 from the right? Now I'm going to plug in 3 into my right piece. So that's 9 minus 2 times 3. Okay, and that gives me 9 minus 6, which is 3. Is the limit from the left equal to the limit from the right? No! No, so it's not continuous. We can say g is not continuous at x equals 3 because the limit as x approaches 3 from the left of g of x does not equal the limit as x approaches 3 from the right of g of x. You could also say, like another justification too, something that would be comparable to this is because the limit of g of x as x approaches 3, just as it approaches 3, does not exist. So if the limit doesn't exist, then it's not continuous. All right, so there's our justification. Example number 4. Find a value for c such that the function k of x is continuous for all real numbers. Okay, so I just briefly want to go ahead and recap. What does it mean for continuity? It means that the limit as x approaches c from the left of a function, for this it's going to be k of x, it has to be equal to the limit as x approaches c from the right of k of x, which has to be equal to the actual function value, k of c, whatever that value is. Okay, now they say find a c value such that k of x is continuous for all real numbers, So I want to go ahead and inspect. Just looking at this top piece here, this is a polynomial. This is going to be continuous everywhere, and so is the bottom piece. That's also a polynomial, continuous everywhere. The only value that I am concerned about is at 3, and they want it to be continuous. So if it is continuous, here's what they're saying. Well, the limit as x approaches 3 from the left of k of x, I'm going to go ahead and find that. I'm going to find that really quickly. So if I plug that in, that's c times 3 squared minus 2 times 3. Okay, and this looks like it is 9c minus 6. 9c minus 6. Okay, I want that to be equal to the limit as x approaches 3 from the right of k of x. I'm just going to go ahead and plug in 3 into my bottom piece. 5 plus 3. No, 5 plus c. It's not an x value. It's 5 plus c. I want those two values to be equal. They have to be equal. And then additionally, right, k of 3 has to be equal to that value also and defined, which k of 3 is defined. That's going to be 5 plus c, whatever that is. Okay, so how do I find c? Well, if it's continuous, the limit from the left is going to be equal to the limit from the right. I'm just going to take 9c minus 6 and set it equal to 5 plus c. And then we'll go ahead and combine like terms. Take away a c, add a 6, and it looks like we get 8c is equal to 11. Divide by 8. C is equal to 11 over 8. Done. That's it. That is it. That is the formal definition of continuity. So again, just to recap, a function is continuous, really part 3 here, when the limit of the function as x approaches c is equal to the function value itself, f of c. I hope in this video you learned what continuity is and how to check for it. Go ahead, give me a thumbs up, like it, subscribe. Catch you in the next video. Peace.